Bonjour, bon après-midi, mesdames et messieurs. Buenas tardes, damas y caballeros. Good afternoon, ladies and gentlemen. My name is Sung-Hoon Kim, and I'll be your MC for our SkyTalks. I'd like to welcome you to ICAO SkyTalks 40th Assembly version. We come to you live. Over the next 2 weeks, we have 68 presentations from aviation industry professionals for you. So if you have missed a few of them, I would invite you to go on YouTube and go to the ICAO channel to have a look at what we've had for you so far. We've had some great presentations, and continue along today, we have presentations regarding the environment. Now, if you have questions, please make sure to wait till the end of the presentation. You can line up and get to the mic here and ask OA. Now, our next presenter will talk about green solutions, reducing the environmental impact of aviation through technological innovation, which tells you that we can go forward and go green at the same time. Would you please welcome Dr. Neil Dickson, Chief of Environmental Standards at ICAO here at the Air Transport Bureau. So without further ado, let's come in.
Thank you for the introduction. So this afternoon, I'll be talking to you about green solutions and reducing the environmental impact of aviation through technological innovation. Actually, I like the way you described it in the overview. It's going green while also moving forward. So this presentation will cover three topics. It will cover aircraft noise, local air quality, the emissions that impact local air quality, and the emissions that impact the global climate. Now, what I've actually also just described to you are ICAO's three major environmental goals. So to limit or reduce the number of people affected by significant aircraft noise, to limit or reduce the impact of aviation emissions on local air quality, or LAQ, and limit and reduce the impact of aviation greenhouse gas emissions on the global climate. Now, what you'll also see on this slide is a front cover of our latest environmental report. So the Environmental Report 2019, it was released a few days ago. This covers all our work across all those topics and more. So what we know about aviation is that it's a technologically driven sector. It always has been. You go back to the dawn of aviation. It was pioneers and innovators in technological sectors that drove this sector forward. That's no different today. And with regard to environmental issues, these technologies address noise, LAQ issues, and the challenges associated with climate change. And of course, with all these three things, there are interdependencies in ICAO and in the industry and in our member states that are considered. So interdependencies between noise, fuel burn, and emissions. And it's extremely important to recognize this integrated, holistic approach, both here in ICAO and across the entire sector. What we do in ICAO, of course, is make standards and recommended practices. And in order to make those standards and recommended practices, we really need to understand technology. So what we've done in the past is to run independent expert reviews, where independent experts from across the sector come together and tell us where the industry is going in terms of noise, emissions technologies, and CO2 reduction technologies. We actually have just completed one of these. It was approved by our ICAO Council in 2019, and this one is the first time that this technology assessment and the technology goals presented to the ICAO Council was done in an integrated manner. So we aligned noise, CO2, and local air quality goals. And this publication is available on our website, and details of it in our environmental report. So I'll start with noise. So I'll deal with each of the topics one by one. So as I've told you, the aim is to limit and reduce the number of people impacted by aircraft noise. Well, actually, how do we do that? Well, in ICAO, we have what we call our balanced approach to aircraft noise management. One of the significant pillars to this policy is technology and reduction of noise at source. Now, to encourage the latest technologies on board the aircraft, we have Annex 16 Volume 1, Annex 16 to the Chicago Convention. And Annex 16 Volume 1 sets certification standards for manufacturers to meet the latest regulatory levels on noise. And what you see on this slide is the progression of these noise standards since the early 1970s all the way up to today. So you can see that ICAO, through assessing technology and then making standards more stringent, encourages the latest technologies with regard to noise on board aircraft. But I don't really think you want to just hear about the standards. I think you want to also hear about how that actually happens. And so in terms of noise reduction technologies, what I can tell you is that since the dawn of aviation, aircraft noise has been reduced significantly by something in the region of 75%, and this was done by a multitude of different technologies. Some of them that you see here in terms of modern innovations, whether it's improved geometry of the landing gear to reduce noise on landing, acoustical performance improved by liners in the engine, or engine technologies. All these add together to reduce the noise impact of the aircraft. What I would also highlight to you, of course, that there is some interest in supersonic aircraft in the future. And what we understand is that we'll see a supersonic aircraft maybe entering service in a time frame around 2025. And ICAO is also carrying out work to understand and to also set standards recommended practices to deal with the environmental impact of those future aircraft. So moving from noise to local air quality. Well, in exactly the same way as the technology standards set for aircraft on noise, we also have Volume 2 to Annex 16, which regulates aircraft engine emissions. These cover hydrocarbons, carbon monoxide, oxides of nitrogen, smoke, and non-volatile particulate matter. Broadly, what they do is set a standard that focuses on emissions released below 3,000 feet and those that impact local air quality. And again, in terms of the emissions reduction technologies, the industry really continues to move forward to make progress on combustion design to reduce emissions that impact local air quality in the vicinity of airports. And these emission reductions are being achieved through a combination of engine cycle improvements and advanced combustion technology. And the most recent combustion technologies that demonstrate this progress are, for example, lean burn combustion technology and also rich quench lean. They provide significant reductions in oxides of nitrogen. Now, we also consider interdependencies across all our standards. Of course, when we set standards, we also consider the impact of a noise standard on fuel burn, a fuel burn standard on local air quality. That's extremely important and something that we take very seriously here. We also set brand new standards, and in fact, in early 2020, the ICAO Council will consider for adoption a brand new non-volatile particulate matter standard for mass, a number that was recently developed by our Committee on Aviation and Environmental Protection. Now, while historically the international focus has been on oxides of nitrogen, this new standard really completes the suite of engine emissions standards. And while we're talking about interdependencies and a multitude of ways of reducing the environmental impact, it's also quite interesting to note that sustainable aviation fuels can also reduce NVPM emissions significantly. And I'll come to sustainable aviation fuels a little bit later in this presentation. So I've told you about noise. I've told you about local air quality and the engine emissions that impact it. Now we'll talk about climate change. For all of you here, I'm sure you're very aware of ICAO's global aspirational goals to address the impact of international aviation on climate change. They're carbon neutral growth from 2020 and a 2% annual fuel efficiency improvement through to 2050. Well, those aspirational goals are the main policies of the organization on climate change, but we also have a roadmap to get there. And that's what we refer to as our basket of measures, whether it's aircraft technology improvements, operational improvements, sustainable aviation fuels, or our market-based measure, the Carbon Offsetting Reduction Scheme for International Aviation, or CORSIA. And what you see on the graph on this chart is that basket of measures and how we reduce the CO2 emissions down to our carbon neutral growth from 2020. Now, what I'll do is I'll focus here on some of the innovations across these pieces, with a particular focus on technology. So, in terms of innovative technologies in this particular segment, what I mean by that is reducing greenhouse gas emissions from aviation, both in the sky and on the ground. What I also mean is new innovative technologies for aircraft operations and infrastructure. And this can involve improving energy efficiency, so reducing the fuel burnt by the aircraft itself, or green airport policies to reduce the carbon footprint of the airport, or indeed the aircraft on the ground. I'll also describe to you in this presentation some of the initiatives on alternative energies. So we have our sustainable aviation fuels. We also have green and renewable energy sources. So to build upon that, and the fuel efficiency and aircraft technology, aircraft today are 80% more fuel efficient than they were at the dawn of aviation in the 1960s. This is an incredible achievement, I'm sure you'll all agree. And it's the ICAO standards, policies and recommended practices that have ensured that these latest technologies have been incorporated in aircraft design. And very recently we adopted our Annex 16 Volume 3. So I've told you about noise, Volume 1, Volume 2 on emissions. We also have Volume 3 on called our ICAO Aeroplane CO2 emissions standard. That applies to brand new type aeroplanes from 2020 and then in production type aeroplanes from 2023. But actually, in terms of reducing the emissions, well, I'm actually talking about reducing the weight of the aeroplane, improving the aerodynamic performance of the aircraft, and also propulsion technologies. And let me just build a little on these concepts. So there are continuous efforts across the industry in terms of propulsion. And this means higher bypass ratio engines, for examples, advanced engine operating cycles, and new concepts like open rotor, which you can see in the middle of this screen. Also in terms of aerodynamics, laminar flow technologies can give you significant drag reductions, so then significant fuel burn benefits. And also winglet technologies can give you significant drag reductions and fuel efficiency benefits. And I show you an example here on this slide. And also structure and design. And we've seen a lot of a large increase in the use of composite materials across the industry, whether it was composite wing or composite fuselage, most recently on the new type aircraft that we see operating today. And also some examples are shown here of 3D printing, which adds an efficiency to the manufacture of the aircraft, while also potentially reducing weight. So all those technologies are being used to really make strides and advances in aircraft technology. So now I'm going to just push the boundaries, and I'm going to talk a bit more about electric and hybrid aircraft, and the electrification of the aviation system. Before I start, I just want to impress on you how exciting this area really is. And those of you that were at our innovation fair over the last couple of days prior to the assembly will have seen urban transport startup companies and large organizations coming here to show what they're doing. So it's a very exciting time to be in this sector. But I also want to impress on you the challenges associated with this. Now, these are real breakthrough technologies. And on this slide, at the top, I show you an example of an urban mobility transport, a concept that we may well see flying around up to 2030 and beyond. When it comes to the bigger airplanes, the airplanes that you all traveled here today on, well, the challenges are somewhat more stark. So what I want to describe to you is is an issue of course, there are ways of electrifying the aircraft. We can go for a hybrid type approach for the engine. There are some concepts where one engine could be electrified. These will reduce CO2 emissions, and that's of course very welcomed, and the reductions will be very important in the future. But electrifying a large aircraft has its challenges because of the energy density of current lithium-ion battery technologies. And just to give you one broad number, you have to carry energy on board your aircraft to power your aircraft, to carry out your mission. A current aircraft that you all travelled here today on is powered by kerosene, and kerosene has an energy density of around 42 to 43 megajoules per kilogram. Well, the current energy density of a lithium-ion battery is somewhere around 1 megajoule per kilogram. So therefore, you can see the challenges in terms of weight. I told you how important weight was in terms of reducing CO2 emissions for the aircraft. So therefore, if you use a technology that is somewhere between 40 to 50 times heavier in terms of energy density, then that's a real issue. It doesn't stop it being used in ways to reduce CO2 emissions in terms of hybrid and maybe single engine uses, but there are some significant challenges in terms of taking the industry from liquid fuel that we use today to full electrification. But when we consider all of this, another important thing needs to be considered. We need to consider this on a full life cycle basis. So even if you electrify the aircraft, you also need to ensure that the energy you use the energy used in your battery to propel your aircraft is also renewable. So all these things together, as you can see, we really need to consider all these things in order to achieve our aspirational goals. The advances are moving forward. We really are making significant progress. And here in ICAO, we really monitor the industry moving forward. And for those of you that want to visit our website, we have a platform where we're trying to collate all these initiatives and efforts. It's called the Electric and Hybrid Aircraft Platform for Innovation, or EHAPI, and it contains all these initiatives and innovations. So we also have significant work going on sustainable aviation fuels within the sector, and I just want to tell you what I mean by the phrase sustainable aviation fuel to start with. Well, first of all, it's a drop-in fuel, so it's chemically identical to the kerosene that we currently use, which means there's no changes to the aircraft and engine configuration. So it ensures compatibility with the current aircraft systems, delivery mechanisms, and of course, safety is primary, so it matches all the safety certifications. But of course, there are challenges here in terms of the sustainability of the fuel. So where you got your feedstock from. Feedstocks can come from waste, oils, or from a grown crop. Well, as we stand right now, there are a multitude of feedstocks, and we have 6 conversion processes to go from those feedstocks to a fuel. And of course, there are challenges. The challenges of the price of the sustainable aviation, fuel, the production capacity of the sustainable aviation fuel, and also setting a level playing field with ground transportation. Now, all this work is really progressing in the industry, and here in ICAO, we also have our 2050 vision for sustainable aviation fuel, which has told us, our member states have told us to carry out a stock taking process to understand where the industry is going, and there's plenty more details on our website. So these are really on board ways of reducing CO2 emissions on board the aircraft. Now I just want to talk to you about some projects that we've worked on as ICAO, and that are being worked on across by the international community in terms of airports. So there are many ways to reduce the CO2 footprint of the airport. In fact, I'm aware that there is a significant push to meet carbon neutrality by 2050 by a number of airports globally, and how they might do that. So there's the CO2 from the airport. There's also the CO2 used on the ground by the aircraft. And those of you familiar with the industry will know that in the tail of the aircraft you have an auxiliary power unit. This burns jet fuel and produces CO2 emissions. If you switch that off, of course, you have an immediate benefit to the climate. So here in ICAO, we worked under the auspices of our ICAO European Union project, and we set up a pilot. What we wanted to do was to prove that you could build a solar panel array at an airport, electrify a gate, then when the aircraft pulls into the gate and the passengers disembark and then embark, instead of using an APU, it's plugged into the gate using renewable energy. And we did exactly this at Douala International Airport in Cameroon and Mombasa International Airport in Kenya. We also carried out a very similar project with UNDP GEF in Jamaica. Now, these projects show that this can be done. And on our website, you'll find all the information on how to replicate these projects. And in fact, in another SkyTalk later in this week, you'll also find more information on the exact details of these projects. So that's what we call solar at gate. But there are also initiatives. I've listed a few on this slide. For example, the geothermal power plant at Vancouver International Airport, and often the airports in the Netherlands switching to 100% of wind energy. What we do know standing here right now, there are well over 100 airports working on some kind of solar-based initiative. So this brings me towards the close of this session. What we've talked about is, of course, the innovations in noise, local air quality, and greenhouse gas emissions, and the ICAO policies that encourage all these technologies into the marketplace. I've also given you an overview of all the innovations or a set of the innovations that go on. This is a very exciting time, whether you work in noise, local air quality, or in climate, and there are plenty of innovations going on moving the sector forward. But what is definitely the case is that we need a broad spectrum of solutions, and this is necessary in order to further reduce particularly greenhouse gas emissions from international aviation. There is not one single solution. We have our basket of measures in ICAO, and there are many solutions. In particular, through technologies and innovation for aviation system, these should be developed, supported, and accelerated. I also hope what you've also got from this presentation is some of the successes that have gone in the past. So an 80% improvement in fuel efficiency by the industry since the dawn of aviation, but also some of the challenges involved, whether it's in technology, whether it's in sustainable aviation fuels, whether it's on things like the electrification of the of aircraft. I really hope you've had a full overview of those successes and challenges. And of course, as ICAO, what we continue to do is to facilitate and collaborate among our member states and the aviation industry stakeholders to really try and understand where the industry is going and identify all the best solutions and innovations moving forward. So thank you very much for your attention, and I'm happy to take any questions.
If you please, if anybody has questions, please step up to the mic. Well, I guess that's it. Thank you.
No, I do have.
Oh, okay.
I was just waiting and hoping somebody else would ask a question. For me. Do I have to go
Yes.
there? Okay.
Yes.
Thank you very much for your presentation. My name is Jennifer Shamala. I'm with the Kenya delegation. I'm from Kenya. I am interested in the issues of noise pollution, especially with regards to the decibels. And you did, in your presentation, when you referred to noise, you talked about at landing. But what about when you fly over residential areas, when you fly over hospitals, at times that people are supposed to be resting in residential areas and in hospitals when they're supposed to be recuperating? And you didn't really describe it in terms of decibels and the reductions thereafter.
Okay, that's a very good question. Yeah, the technology example I gave was the landing gear, which would have a particular approach on a particular impact on both takeoff and approach. Our ICAO noise standards actually account for what we call a landing takeoff cycle. So the ICAO noise standards ICAO noise standards aim to encourage the latest technologies on board aircraft, and they do that by setting a very stringent certification scheme. And it does describe the various different modes of operation in a landing takeoff cycle. And what we know historically, that the ICAO standards have encouraged these technologies to reduce noise bit by bit as we move forward. Okay, so the last time we made our standard more stringent was 2013, and we made the standard more stringent by 7 what's called EPNDB, which is our metric that we use to underpin the standard. So I suppose in summary of your question, the important thing is that the ICAO standards are to encourage technologies into the marketplace. We've made the standards more stringent over time, and they have reduced the noise, or their aim is to reduce the noise in and around the vicinity of an airport.
And the flight plan as well, within when you come into landing and timing. What about timings?
You really have to understand that these are technology standards, so they're trying to encourage. They do not.
Okay, they don't take into account.
They do not exactly mimic the operation of an aircraft. What they do, they're representative of the operation of an aircraft, and they encourage technologies into the marketplace. So they do result in real reductions in the vicinity of an airport. But I can't comment on an exact operation or an exact particular mode. What I can tell you is the certification scheme is representative of operations. But of course, they have to be employed across the entire industry.
Are there any questions? Well, thank you, Dr. Dickson.
Thank you.